But it's been a great partnership out here. It's great to work with the landowners. I learned a lot working with Dean and Henry Fuchsa and Hugh O'Neill. It really was part of my education of learning about Oklahoma. So I'm going to talk a little bit today about some of the agronomic discoveries that have occurred out here at the Wheat Pasture Research Unit or have been affiliated with it. And it doesn't show up real well. That's a picture from out here, you know, just cattle grazing on wheat pasture. One of the things that has really helped our program in plant and soil sciences was incorporating a grazing aspect into our wheat breeding program. So Dr. Carver did a lot of work and actually published a paper looking at incorporating grazing by cattle into the wheat breeding program. And what they found was there was no advantage on the grain side to introducing a grazing component into your wheat breeding program in terms of which varieties you selected for release. There was no disadvantage, so they performed equally as well in grain-only systems. But not having the grazing component was a big hindrance to releasing varieties or selecting varieties that were adapted to dual purpose. So Endurance, Duster would have been a couple of the first varieties that were released that were screened as elite lines out here. Gallagher, you know, would be another one that was screened out here, as a matter of fact. Yeah, here's a picture of Gallagher. Whenever we were evaluating Gallagher out here as an experimental line, it was a funny thing, Wayne. I'd never seen cattle do this before, but this is Gallagher right here, and they would graze those Gallagher plots. I mean, they would just slick off the ground. They would graze it down to nothing, and they would get to the alley in between the varieties, which would have been probably Jagger at that time, and they would stop and turn around and go back to the Gallagher. I've never seen anything like it, the selective grazing of that variety. So, you know, I thought I was really on to something here. Hey, we've got a wheat that 9 out of 10 cattle prefer the taste of Gallagher. We're really on to something. Next year, they didn't care. They grazed them all the same. So it was a one-year thing. Dr. Horn and I tried to develop all these theories about sugar accumulation and everything, and it was just a one-year thing. So there's the same plots of cattle. Again, it amazed me the way they would just find the end of that variety, stop, turn around, and go right back on it. So doing variety testing out here and agronomic research in a grazed system does create some problems. Again, doesn't show up real well, but I never could figure out a way to train the cattle to walk in the alleys. Or they deposit nitrogen, but they never deposit it equally across all of the plots. So it does create some challenges, but in spite of that, we were able to come up with some discoveries. One of the first things that my predecessor at the time, Gene Krenzer, started talking about was high temperature germination sensitivity. And this was a phenomenon that had been identified in the Pacific Northwest. It had been something they had dealt with for a while, but we really hadn't pinpointed the way it affected our wheat pasture and being able to plant really early here in the southern plains. And what they found, you know, of course, some varieties germinate well in hot soils. Others don't. 2174 would have been an example of a variety that just, you know, didn't germinate that well in hot soil conditions. So it wasn't a new discovery, but the ability to screen all of the varieties that were available to our producers in the southern plains and report that information so you could use this as a selection criteria whenever you are selecting a variety was something new that came out of the Wheat Pasture Research Unit, and something that was funded by the project, the continuation of this work. The same way with coleoptile length. So if you've been around long enough, you probably remember growing wheat varieties that were about that tall at harvest, right? So what did we do? When we had a lot of lodging problems, we bred them to be about that tall so they would stand better and we could put more nitrogen on them and raise more grain. So whenever we reduced the height of the mature plant, we also reduced the length of the coleoptile. So it limited our ability to be able to sink those seed to moisture to get a stand in late August, early September. So the recommendation converted from sinking it to moisture to these newer semi-dwarf varieties, you really need to dust them in and hope for rain. The other thing was, again, like high temperature germination sensitivity, we had the ability then to be able to screen our varieties for coleoptile length. Some of the early work that was done here at the Wheat Pasture Research Unit was planting date work, looking at the effect of early planting. What effect does early planting have on forage yield? What effect does early planting have on grain yield? And this is some work from Gene Krenzer. And again, what he found was that your forage yield, once you get past mid-September, your potential to produce a good forage crop decreases significantly. But if you plant the 1st of September, you've reduced your grain yield potential. So a lot of work in this area kind of identified September 15th, September 10th, mid-September as the optimal planting date for a dual-purpose system. And without that, without this data, we really didn't have any information to help us identify the optimal planting date, and that's still our recommendation today for dual-purpose wheat. Plant mid-September, and it's a balance between forage yield and grain yield. Looking at forage yield, some other work that was conducted out here would have been seeding rate and seeding rate by variety work. Dr. Reuter, I know Dean was just commenting to me earlier how much he missed and how nostalgic he was for those different variety studies that you used to put out here. He said he really enjoyed vacuuming out the drill and changing varieties pretty frequently. But that was some work that was conducted out here. And again, what we found was that the more seed you planted, the more forage you were going to have, and the more quickly you were going to have it. I think prior to some of that work out here, Dr. Horn, most of the time people would plant 60 to 90 pounds, a bushel and a half per acre. And what Dr. Krenzer found was that if you would bump that seeding rate up to 2 bushels per acre, you're going to have more forage, you're going to have it more quickly. In later work, we found if you'd bump it up to 3 bushels per acre, even then it's going to increase the amount of forage that you have and how quickly you're going to have it. Low pH. You know, the variety tolerance to low soil pH has become an integral part to our wheat breeding program. That's one of the reasons that Endurance and Duster, Gallagher have been so successful, is that they can tolerate low soil pH conditions. And a lot of that work looking at how low pH affects different wheat varieties has been conducted in different parts around the state, but one study right out here really established that threshold of about 5.5 pH being the threshold where production really starts to drop off. And we identified varieties that were tolerant to low soil pH conditions. And again, as part of the project, we were able to screen varieties and release that information and let people know, hey, you know, if you've got a low soil pH and you want to grow forage, you'd probably want to avoid some varieties, and there are others that you may want to choose. The impact of low soil pH in a non-tolerant variety is much greater on forage production than it is on grain production. And again, without looking at this in a grain system, we wouldn't have that information. One of the other recommendations of this work would be to apply DAP in furrow. One of your biggest limitations is accessing phosphorus in a young seedling plant. So by applying 50 pounds of DAP in furrow, or 10 gallons of 1034O, you are able to get phosphorus to that seedling plant and greatly increase your forage production. Okay. So one of the other things that has been conducted out here at the Wheat Pasture Research Unit, I think since the first year, Dr. Horn, would be variety testing, where we can screen different varieties that are already released and look at how well they tolerate grazing, their ability to produce grain after grazing. And the first 7 years out here, we planted the same varieties around the 1st of September and then just fenced off part of them. So they were planted on the same date, and one set of plots was grazed, the other set of plots was not grazed. But they were both planted really early. So if you remember that slide earlier, when I was looking at forage yield versus grain yield, we showed that if you plant that early, you're dinging your grain yield a little bit. So the first 7 years, whenever both plots were planted early, we looked at some long-term data, and a 40 bushel grain yield in the non-grazed plots would have been a 37 bushel grain yield in the grazed plots. So, you know, there was a yield penalty, about a 10% yield penalty for grazing, but it depended a lot on the year. You would have funny years like 1992 where grazing actually increased yield because we were using less water than what we had used in the past. So using some of that data that Dr. Krenzer had collected, they figured out that probably we should be planting at different times of the year. And starting in '99, we started planting the grazed plots in the 1st of September and the non-grazed in mid-October to kind of truly compare the two systems. And what we found there is that a 40 bushel non-grazed yield equated to about a 34 bushel grazed yield. So if you kind of do some quick math on that, you can kind of figure there's about a 6 bushel per acre. If you have 40 bushel yield potential, there's about a 6 bushel per acre yield penalty for grazing wheat pasture. And about half of that, about 3 bushels of it, or about 10%, is because you're planting a month earlier than you really should if you're going for grain. And then about half of it is because of the grazing by cattle. So there is a yield penalty associated with it, but there are ways that we can reduce that yield penalty by pulling the cattle off at optimal timing, which would be first hollow stem. And I would say probably out of all of the work that's been conducted associated with this project, the first hollow stem is what has gotten the most attention. Heath is going to talk later today, show you how to measure first hollow stem and how to check for it in the field. But just a little bit of history. I think prior to identifying first hollow stem, it was more of a calendar date method. What, Dean, about March 10th, March 15th, we'd remove cattle from wheat pasture. And what Dr. Krenzer did was identify first hollow stem through research as the optimal time to remove cattle from wheat pasture. And some of that early work showed that we were losing, a couple of bushels per day for grazing past first hollow stem. And then Dr. Feasier had to complicate things. And I think some of your work indicated there wasn't, you could graze a week or two past first hollow stem with no problem. So it was kind of a moving target. And we were kind of wondering why this was the case. Well, a few things that we discovered in the work. First of all, there was this common misconception at the time that as long as you pulled the cattle off before they were actually removing the developing grain head, you were okay. That's not the case. Really what we're trying to do is rebuild leaf area that's lost to grazing whenever we pull cattle off by first hollow stem. And that's one of the reasons that we had such variation among years on how grazing past first hollow stem, how much of a yield impact that had. It's because of the ability of the plants to recover. If you're in a good year with good soil moisture and good ability to recover that leaf area, you can graze 2 weeks past first hollow stem and probably be okay if you don't have a really heavy stocking density. In a dry year where the plants are struggling to recover leaf area, first hollow stem may be a week or two too late. So it is a bit of a moving target, and we were looking at how to address that. I had a graduate student, Dylan Bucci, who was kind of interested in this topic, and we did simulated grazing looking at different mowing heights. So we had 3 different mowing heights where one, we basically scalped the plants and kept them mowed very short to simulate a really heavy stocking density. And then we had other plants that we or other plots that were mowed at about a 3 to 4 inch height, and then others that were mowed to about a 6 to 10 inch height, okay? To try and simulate different stocking densities with different growth habits on wheat. And what we found was that the harder that you graze, the more intense the simulated stocking density, the greater the impact on final biomass and the ability of the plants to go ahead and produce grain. We found that if you maintained about 60% ground cover, you could optimize grain yield within the dual purpose system. So the ground cover was key in optimizing grain yield within that dual purpose system. So we identified first hollow stem, and then taking it a little bit farther, looking at ground cover. I don't know where the next step in the process will be, Dr. Rocatelli, but it'll be interesting to see where this research goes.